All right, hi guys, it's Mrs. Harris. I am going to do the first homework assignment as a key and explain some of them. So the first one, all the faces are triangles, so this should be a pyramid. A prism, remember, has has to have two parallel bases, and this clearly does not have any. This has one base, so that's what. Cone has to be a circular base, so that is not true here, which is why it's not a cone. And then a cylinder, we should know what a cylinder is, but that also is has two circular bases, so it's not that one. Okay, just some shape vocab there. Number two, if a rectangle is revolved around one of its sides. Okay, this is really cool, but here's a rectangle. I'm going to show you guys a applet of this as well. Here's a rectangle, and basically what I want you thinking of is if I take one of its sides, I'm just picking one, and I make this an axis, so that is like a cement pole, that's staying still. We're going to swing this part around that. What shape is going to be created? And I want to show you, maybe, oh, we got all sorts of stuff going on. Hold on a second. I want to show you what's going on with this. So we're rotating a rectangle around one of its sides. So take a look here. If I can get this to work without my mouse. Shoot, I'm gonna have to, hold on a second. Okay. If you rotate a rectangle around one of its sides, take a look at what's created, right? That cylinder. So they're rotating it around the bottom side here. I didn't know if I could make it, no. They're rotating it around, see the cylinder? So if I go back to the homework page here, they're basically they're taking the rectangle and rotating it around one of these horizontal sides here, and it's creating a cylinder. So that one's pretty cool. That one should have been 3. Sorry, I didn't write the answer up here. This one was 2. Which of the following must be true about the faces of the prism? So the faces are the shapes, right? These are the faces. So they're 2 pentagons, it looks like, on the top and on the bottom here. And it looks like this prism is oblique. Immediately I see, like, it doesn't look like it's standing up straight, correct? So that's an oblique prism. There's 2 pentagons, and then it looks like a series of parallelograms around the outside, right? There should be 5 parallelograms. So there are a total of 5 faces. That's false because there's 7 of them, right? Top, bottom, and then 5 around the sides. All non-pentagon faces must be rectangles. This is no, because it's not right. There's not right angles in this case, so that one's not true either. Those aren't rectangles, so that would have to be a right angle right there, and it's not. There are 5 faces that are parallelograms. I think this one seems like it's true. You guys agree? Because those are these 5 faces. I'll highlight them. These look like they're all parallelograms to me, yeah. And there's 5 of them around the outside, so that one I think is it. There is only one pair of congruent faces. Not true. I think the top and the bottom are congruent pentagons, and then I think probably if this is a regular pentagon, then all those parallelograms are going to be congruent as well, so that's not necessarily true. So this one should be free. If right triangle ABC shown was rotated around this segment, what would the solid produced look like? So if you can picture, this is going to be staying put. This piece we're rotating around, that stays put, and the rest of this is going to swing around. You picture what that's going to look like. It's going to look like choice 1 over here, this cone. So I'll show you an applet of that. That is right here. Rotating this triangle, take a look. See, rotating the triangle. There's the cone. This one's just kind of cool to show you what happens when we rotate a trapezoid. See how that's called a truncated cone, when it's the cone without the pointy part, basically. So there's the truncated cone being rotated. That's just cool. Okay, so 4 should have been 1. So far we have 2, 3, 3, 1. Okay, next page. This one says, oh no, I can't see it. Which of the following shapes could not be a cross section of a cone? Okay, so here's our cone. And cross sections is like a little 2-dimensional slice here. So obviously we could get a circle, right? If you just slice horizontal to the base. So we could definitely get this. So this is not what we want here. We could get a triangle if we go straight through the top, perpendicular. I want to show you guys a little demo that I have. Here's the cone, and look at the cross sections here. So if I do, there's the different cross sections. There's a triangle straight through the apex. That's what it's called at the top. If you tilt it, see how you get that nice, the rounded top there if you go through a slanted cross section. Cool. And then it's an ellipse shape until you get exactly parallel with the base there, and then that's going to be a circle eventually. I don't know if I'm going to be able to get parallel to the base, but so there you go. Very cool. So our answer here should, it's not this, we can get that. We know we just saw when you slice perpendicular. So it's not this. That's if you slice a little diagonally. This one's if you slice perpendicular to the base, so that's not the one we want. So the only one that can't be produced is this. It's always going to have that rounded edge. So this one should be 3. All right. The definition of a sphere is a 3-dimensional version of the 2-dimensional shape, the circle. All points are equidistant from a fixed point here. So great, every cross section of a sphere will be a circle. Any slice you take, no matter which direction you take it from, it will be a circle. And a sphere can be created by rotating a circle around a diameter. We'll talk more about spheres later, but that's just kind of cool to think about. And then this one, if this circle was rotated around this line, so it's going to kind of swing around like this. What is this going to look like? If you guys can picture this, it's kind of cool. Some of you probably can picture it fine. It's going to look like? It's going to look like this torus. The shape's called the torus. I know some of you use it in DDP, but it's like a donut shape. It's called a torus, and that's what's going to look like if you swing it around. This is just an example of the y-axis. That's kind of fun too. So torus is the technical name. We can say donut shape, just so you know what we're talking about. But there you have it. Nice work, you guys. Until next time.